Hello everyone, welcome back to our channel KSS Gurukul. Today in this video we will learn about integers under class 7 math. Before that, if you have not yet subscribed to our channel, please subscribe our channel and press the bell icon to get new video updates. First, let's know the properties of addition and subtraction of integers. First come to closure under addition. Closure property of addition of integers says that sum of any two integers is always an integer. We can say integers are closed under addition. For example, 5 and minus 8 are two integers. Now 5 plus minus 8 equal to minus 3, which is also an integer. Thus, we can say for any two integers a and b, a plus b is always an integer. Secondly, closure under subtraction. Closure property of subtraction of integers says that difference between any two integers is always an integer. We can also say that integers are closed under subtraction. For example, minus 9 and 2 are two integers. Now, minus 9 minus 2 equal to minus 11, which is also an integer. Thus, we can say for any two integers a and b, a minus b is always an integer. Thirdly, commutative property. Commutative property of addition of integers says that for any two integers a and b, a plus b equal to b plus a. We can say addition is commutative for integers. For example, minus 3 plus 8 equal to 5. And 8 plus minus 3 is also equal to 5. Thus, minus 3 plus 8 equal to 8 plus minus 3. However, subtraction is not commutative for integers. You can understand it through an example. 5 minus minus 3 equal to 5 plus 3 equal to 8. And minus 3 minus 5 equal to minus 8. Thus, 5 minus minus 3 is not equal to minus 3 minus 5. Fourthly, associative property. Associative property of addition of integers says that for any three integers a, b and c, a plus b plus c equal to a plus b plus c. We can also say addition is associative for integers. For example, minus 5 plus 2 plus 3 equal to minus 5 plus 5 equal to 0. Likewise, minus 5 plus 2 plus 3 equal to minus 3 plus 3 equal to 0. Thus, minus 5 plus 2 plus 3 equal to minus 5 plus 2 plus 3. However, subtraction is not associative for integers. Fifthly, additive identity. Additive identity is a number which when added to any given number, the result do not change. It is the number itself. The number 0 is the additive identity, as adding 0 to any given number do not change its value. For example, 3 plus 0 equal to 3, minus 5 plus 0 equal to minus 5, 0 plus 0 equal to 0, etc. Thus, for any integer a plus 0 equal to a equal to 0 plus a. Multiplication of two integers. The process of multiplication of two integers is like this. Step 1. Simply multiply the integers without sign, that is as whole numbers. Step 2. The product thus obtained should be assigned a sign according to the following rules. If both the integers are positive, then the product is positive. If both the integers are negative, then the product is positive. If one integer is positive and the other is negative, then the product is negative. For example, -3 into -7. In step 1, we will multiply -3 and -7 without sign. That is as whole number 3 and 7. Now 3 multiplied by 7 equal to 21. Next, as both the integers multiplied are negative, the product will be positive. Thus, -3 into -7 equal to +21 or simply 21. Likewise, let's multiply -11 with 3. In step 1, we will multiply -11 and 3 without sign. That is as whole number 11 and 3. Now, 11 multiplied by 3 equal to 33. Next, as among the integers to be multiplied, one integer is positive and the other is negative, the product will be negative. Thus, -11 into 3 equal to -33. Multiplication of multiple integers. First step is the same to multiplication of two integers. That is, multiply the integers without sign. That is, as whole numbers. Next, the rules are like this. If all the integers are positive, then the product is always positive. If there are negative integers in the multiplication, just count their number. If there are even number of negative integers, then the product is positive. And if there are odd numbers of negative integers, then the product is negative. That's all. For example, -5 into 7 into -2. In step 1, we will multiply -5, 7 and -2 without sign. That is as whole number 5, 7 and 2. Now 5 into 7 into 2 equal to 70. As negative integers are there and they are 2, that is even in number, the product will be positive. Thus, -5 into 7 into -2 equal to +70 or simply 70. Another example. -2 into 5 into -4 into -3. In step 1, we will multiply -2, 5, -4 and -3 without sign. That is as whole numbers 2, 5, 4 and 3. Now 2 into 5 into 4 into 3 equal to 120. As negative integers are there and they are 3, that is odd in number, the product will be negative. Thus, -2 into 5 into -4 into -3 equal to -120. Now, what will be the sign of the product if we multiply 8 negative integers and 3 positive integers together? The sign of the product will be positive because there are 8, that is even number of negative integers. And what will be the sign of the product if we multiply 5 negative integers and 4 positive integers together? The sign of the product will be negative because there are 5, that is odd number of negative integers. Remember, if negative integers are present in a multiplication, the number of positive integers have no role in deciding the sign of the product. Properties of multiplication of integers. First come to closure under multiplication. According to the closure property of multiplication, for any two given integers a and b, A into B is also an integer. For example, minus 5 and 6 are two integers. Now product of minus 5 and 6, that is minus 30, is also an integer. Thus we can say integers are closed under multiplication. Secondly, commutativity of multiplication. Commutative property of multiplication says that for any two given integers a and b, a multiplied by b equal to b multiplied by a. For example, minus 7 and 5 are two integers. Now, minus 7 into 5 equal to minus 35 and 5 into minus 7 is also equal to minus 35. Thus, minus 7 into 5 equal to 5 into minus 7. And we can say integers are commutative under multiplication. Thirdly, multiplication by 0. For any integer a into 0 equal to 0 into a equal to 0. For example, 2 into 0 equal to 0 into 2 equal to 0. Likewise, minus 3 into 0 equal to 0 into minus 3 equal to 0. Fourthly, multiplicative identity. Multiplicative identity is a number which when multiplied to a number the product remains unchanged. Thus, 1 is the multiplicative identity of all whole numbers, natural numbers and integers. Now we can say for any integer a into 1 equal to 1 into a equal to a. For example, minus 5 into 1 equal to 1 into minus 5 equal to minus 5. 4 into 1 equal to 1 into 4 equal to 4. But what will happen if we multiply an integer with minus 1? We will get the additive inverse of that integer. For example, 5 into minus 1 equal to minus 5. We know minus 5 is the additive inverse of 5 because 5 plus minus 5 equal to 0. Fifthly, associativity for multiplication. According to associative property of multiplication, for any three given integers a, b and c, a into b into c equal to a into b into c. For example, 2 into 5 into minus 7 equal to 2 into 5 into minus 7. Let's verify. 2 into 5 into minus 7 equal to 10 into minus 7 equal to minus 70. 2 into 5 into minus 7 equal to 2 into minus 35 equal to minus 70. Thus, 2 into 5 into minus 7 equal to 2 into 5 into minus 7 equal to minus 70. Sixthly, distributive property. Distributive property of multiplication says that for any three integers a, b and c, a into b plus c equal to a into b plus a into c. For example, 3 into 5 plus minus 4 equal to 3 into 5 plus 3 into minus 4. Let's verify. 3 into 5 plus minus 4 equal to 3 into 1 equal to 3. And 3 into 5 plus 3 into minus 4 equal to 15 plus minus 12 equal to 15 minus 12 equal to 3. Thus, 3 into 5 plus minus 4 equal to 3 into 5 plus 3 into minus 4 equal to 3. The next point of discussion is making multiplication easier. Use of commutative, distributive and associative property of multiplication makes the calculations easier for us. Let's see how. For example, 26 into minus 48 plus minus 48 into minus 36. Using commutative property of multiplication, we can change the position of 26 and minus 48 and write it like this. Minus 48 into 26 plus minus 48 into minus 36. Next, using distributive property for multiplication, minus 48 into 26 plus minus 48 into minus 36 equal to minus 48 into 26 plus minus 36 equal to minus 48 into 26 minus 36 equal to minus 48 into minus 10. The answer is 480. Another example. Minus 41 into 102. We can write it like this. Minus 41 into 100 plus 2. Now, using distributive property for multiplication, minus 41 into 100 plus 2 equal to minus 41 into 100 plus minus 41 into 2, which is equal to minus 4100 plus minus 82 equal to minus 4182. Next, division of integers. The process of division of integers is like this. First step, divide the integers without sign, that is as whole numbers. Next, the following rules have to be followed. If both the dividend and divisor are positive, the quotient will be positive. If both the dividend and divisor are negative, then also the quotient will be positive. Here we should note that for any two positive integers a and b, minus a divided by minus b equal to a divided by b, where b not equal to 0. For example, minus 2 divided by minus 3 equal to 2 divided by 3. Next, if the dividend is negative and the divisor is positive, the quotient will be negative. And if the dividend is positive and the divisor is negative, then also the quotient will be negative. Here we should note that for any two positive integers a and b, a divided by minus b equal to minus a divided by b, where b not equal to 0. For example, 2 divided by minus 5 equal to minus 2 divided by 5. Properties of division of integers. Commutativity. As we all know, division is not commutative for whole numbers. It is also not commutative for integers. We can take an example to verify it. Minus 9 divided by minus 3 equal to 3. But minus 3 divided by minus 9 equal to 1 by 3. Thus, minus 9 divided by minus 3 not equal to minus 3 divided by minus 9. We can write it like this. For any two given integers a and b, a divided by b not equal to b divided by a. Next, division by 0. Note that for any integer a divided by 0 is undefined and 0 divided by a equal to 0 for a not equal to 0. For example, 0 divided by minus 3 equal to 0 and minus 3 divided by 0 is undefined. Division by 1. Dividing an integer by 1 gives the same integer. For example, minus 7 divided by 1 equal to minus 7. 0 divided by 1 equal to 0, etc. Thus, for any integer a divided by 1 equal to a. Now, the last point, that is division by -1. Dividing an integer with -1 does not give the same integer. Instead, it results in its additive inverse. We can say for any given integer a divided by -1 equal to -a. For example, -3 divided by -1 equal to 3. And 3 is the additive inverse of -3 because 3 plus -3 equal to 0. Likewise, 0 divided by -1 equal to 0. And 0 is the additive inverse of 0 because 0 plus 0 equal to 0. This was all about this chapter. Thank you for watching. To get more updates about this subject, please subscribe our channel KSS Gurukul.